Hey guys, it's Sam here, and today we're going to be looking at mostly molecules and how we represent them. So this display right here, this is called a ball and stick structure, just kind of like loose terminology, and it's mostly used because it's very easy to understand and it accurately shows the shape of the general shape of the molecule, and also where the different atoms are in comparison to one another. So this carbon right here is bonded to this oxygen and this hydrogen, and we can see these are double bonded. This is single bonded. So this is kind of what you're generally going to see. This is the atom, or the molecule propanol. But when you're making them, we're going to be using what's called Lewis structures or VSEPR models. And these we use because they're much easier to draw. So what's the difference? So the difference is between Lewis structures and VSEPR models. Lewis structures clearly show what atoms are in the molecule. They're very easy to draw, and they show where the atoms bond. So we can see that 1, 2, 3. But one thing that it doesn't do well is that it doesn't accurately show the shape of the molecule. It does not do this well. The VSEPR model, on the other hand, is more difficult to sketch, but it does display the molecule in 3D space. And right now we're going to learn how it does that, how it does show the molecule in 3D space, and how we can convert one to the other. So the reason we need to use VSEPR is in order to display the molecule in 3D space, and that's important to show because it helps us understand how they will interact with each other. So that's like where electronegative atoms are, exactly how the molecule is structured, stuff like that. So first we need to fill in the atoms that the Lewis structure omits. So here we can see that we definitely know that this is an oxygen. This right here, that's oxygen. We know that. But what are these? And I remember being confused on this part. What does this even mean? So if there is no label for a given molecule, then the vertices between bonds, so where we see right here, are assumed to be carbons. And since we know that carbon makes 4 bonds, any remaining unlabeled bonds are assumed to be bonded with hydrogen. So we take a model that looks like this. So we have our model to start, and it just looks like this. And then we fill in the unlabeled vertices. So this is a carbon, this is a carbon, this is a carbon. And we see that this carbon has 1, 2, 3, so it needs to make 1 more. This carbon has 1, 2, so it needs to make 2 more. And this carbon has just 1, so it needs to make 1, 2, 3 more. And that is how we will end up with the actual picture of the atom. So it'll end up looking a bit something like this. Once we have that done, we can start converting it into a VSEPR model. So when carbon makes its 4 bonds, the atom's electronegativity will ensure that the atoms are splayed out in a triagonal pyramid. So it's going to look something like this, kind of with the ball and stick structure, where there's 1 on the top and the 3 are kind of splayed out, angling down. So it's going to show up in this kind of triangular pyramid shape. However, this rule does not apply when the carbon is double bonded. So when we see something like this, or like this, it's going to lie on a 2D flat surface. So this is where the Lewis structure kind of starts to fall apart, because this shape right here does not accurately display what it looks like. It actually looks something like this. So how do we fix this? So we can display these 3-dimensional bonds using these 2 shapes right here, this and this, the triangle and the dotted line. A bond displayed as a triangle tells you that the bond in 3D space is extending towards the viewer. A bond displayed as ... tells you that the bond in 3D space is retreating away from the viewer. So in this sort of ball and stick structure, we can convert it over to paper by drawing it like this, with a straight line here, or let's highlight this, with a straight line here, a straight line here, a triangle here, and finally, dotted line here. So that can help us accurately show what the model is shaped like in 3D space on a 2D surface. So now we know how to fill in the blanks on a Lewis structure and use the information that we weren't given, and how to turn a Lewis structure into a VSEPR diagram, like so. That's the end. Thanks for watching. Bye, guys.